Hello all. In this video session we will be discussing about how we can pass arrays as function parameters. Okay, so how in this we will be seeing how we can pass array to a function. Okay, so we are explaining it by using a read array function, which is actually for reading elements of an array and storing it into the array. Okay, so we have the main function and program execution starts from main, then int ARR of 3 equal to 1 2 3 is executed, so memory will be allocated for ARR. So when this statement is executed, memory will be allocated for ARR. Okay, here the memory allocation is starting from address 240. I am assuming that the allocation is starting from 240. Usually the compiler allocates memory based upon the memory available, and I am assuming that we are actually storing this array at location 240. Okay, and since we are initialized it with value 1 2 3, the 1 2 3 values will be stored in the array. So array ARR of 0 will be having 1, ARR of 1 will be having 2, and ARR of 2 will be having 3. Okay, then I have declared I and n. Okay, so here memory will be allocated for both I and n. I am just showing the memory allocated for n for the time being, and it is allocated at some location decided by the compiler. I am assuming that it is allocated location 260 and it is having the value 3. Okay, then this read array of ARR comma n is called, and as we know that array name indicates array name gives the address of the array, so we are passing the address of ARR comma the value of n. Okay, so the control comes here, so memory will be allocated for p and n. So this is memory allocated for p. Since ARR is the name of the array, it will be giving the address of the array, that is 240. So 240 will come here and it will be stored inside p. Okay, now here also there is n. So this is our actual argument n, and this is our formula argument n. So here we are passing n by pass by value method. So the value will be copied here, and the value from n3 will be stored to the n in read array. Okay, then after that int I, so memory will be allocated for I, which I haven't shown here, and then after that this statement is executed for I equal to 0, I less than n plus plus I. Read the value and store it at p plus I. Okay, initially I is 0, so p plus 0 means at location 240 we will be reading a value. Let's say I am reading 6, then it will be stored at 240. Then I increments to 1, then again p plus 1. Here also remember about the pointer arithmetic. P plus 1 means p plus 1 into size of the our pointing type. Okay, so this is int, and if we are considering int is having 4 byte size, then the p plus 1 means p plus 1 into size of int, that is 4. So p plus 1 into 4, that is 240 plus 4. So the address becomes 244. So next value, if I am giving 7, it will be stored at location 244. Okay, then after that I again increments and I becomes 2, and we will be checking whether 2 less than 3, which is correct. So again we comes inside the loop, and p plus 2, that is p plus 2 into size of int, that is p plus 2 into 4, that is 240 plus 8, that is 248. So it will be stored at so the next value I am entering, for example if I am entering 8, it will be stored at 248. Okay, then after that again I increments and I becomes 3 less than 3, which is false. Okay, so we will be exiting from for loop. Okay, now here I have used p plus I for reading the array elements. You can also use ampersand p of I. Okay, anyway, we have completed this for loop, and then controls comes out from this for loop, and this function has completed, and then we will be exiting from this function and will be returning to the called function. Okay, so after execution of here, control will come to here, and all this memory will be deallocated with control coming to here, and we can see that if we print the values of ARR, it will be printing 678. Okay, so the changes made in the formal argument or changes made using formal argument affects the actual argument here. Okay, so that you have to remember, since we are passing the address of ARR, the changes made using the formal argument has actually affected the actual argument ARR. Okay, so then after this completes, this memory will be deallocated. Now we will see one more method, that is, we will be passing an array and we will be using an array here. Okay, so in formal argument also we will be using an array instead of a pointer. Then we will see what will be happening. The program logic is almost similar. So here instead of star p, we are just using an array A. Okay, so all these statements are similar. The memory will be allocated for ARR. Okay, these are all assumptions: 240, 244, 248. I'm assuming that they are at this particular location. Again, n. This address is again an assumption. Okay, then after that, read array of ARR comma n is called. Now here we have to observe that here ARR gives the starting address of the array and it is passed to A. Okay, so usually when we declare a statement like int A square bracket, it will be allocating memory. Okay, it will be allocating a different memory. But if we are passing an array to a formal argument like A open bracket close bracket, or if we are passing an array to a formal argument array, then what happens is that it will allocate or it will consider a variable A or an array A which is having the starting address of ARR. So this A will consider ARR's address as its starting address. So we can say that A is actually a reference to ARR. Okay, so if we say here ARR is not accessible, but A is accessible and A will be having the starting address of 240. Okay, since we are passing ARR to an array A, this A will be having the starting address 240. So this ARR A will be pointing to the or will be indicating the same location. Okay, so when this statement is executed, this A will be created and A will be having the address, or A will be an array with starting address same as ARR. Okay, so both ARR and A will be pointing to the same location, and then we have int n. So memory will be allocated for n for formal argument, for formal parameter n, and the value from here is stored here. Okay, value from here is stored here. Okay, so now since this A is having the, or A is referring to the same location that ARR is referring, any changes made in this A will affect the ARR. Okay, we will see that, since now we have seen that A is also an array which is having the starting address 240. So when we read elements, let's say that I am reading an element 6. Okay, so this change will be made at A of I, that is at location 240, right? That is A of 0 is this location, so change will be made here. So if I am entering 6, 6 will be stored here, and when I becomes 1, it will be stored at A of 1. So A of 1 is here. So if I am storing 7, 7 will come here, and then I increments, and okay, 2 less than 3, so I am storing at A of 2. So if I am giving 8, 8 will be stored at A of 2, so 8 will be stored here. Okay, so then I increments to 3, 3 less than 3, which is 4, so again we will be exiting from for loop. Then we comes out of the for loop where A and N will be deallocated, and we will be having this remaining array. And if we print this array, we will be printing the value 678. Okay, so if we use this method also, the changes made in this changes made in this formal argument affects the actual argument. Okay, changes made in this changes made in this formal argument array A affects the actual array argument ARR. Okay, so we can either use here pointer or an array. Both will work the same way as pass by reference. That you have to remember. Okay. Anyway, try out, go through these programs, try to do programs and observe what are the changes that you are seeing. For example, if you print ARR here 240 will be printed, and if you are printing the value of A here, then also the value printed will be 240. Okay, anyway, just go through these examples, try to exercise these programs so that you will get better understanding. Okay, thank you for watching.